الشاتل داخل الانتربرايز مش الانتربرايز نفسها.
ما هو معجب بالدكتور فاروق من 20 سنه، من اكثر من 20 سنه عمل كان يتكلم دكتور فاروق في انترفيو، وهذا كان ساوند مان
ريكوردينج ات جاست ساوند
تكنيشنز.
تكنيشن.
هي جت سو امبريسد لما بعدين مرت الايام صار هو الاكزكتيف
بروديوسر بتاع
ستار تريك. رحنا اسم ولا شطر ولا شطر. انا عرفت الشيء امس لما قريت في السيريز.
طلعت في السيريز.
هذه مطلعانا باستمرار على التلفزيون. لا كل ما الانتربرايز يكون فيها شطر رايح من مكان لمكان يبقى يطلع.
يشيل قد صار
يعني الارض الزراعيه اللي تضيع
اللي تضيع مع الاسف بدل ما تكبر.
اللون البنفسجي البناء على الصحراء عشان نعرف فين ازاي وهاو ماتش هاو برسنتج كذا كذا.
طيب ليش يصير بنفسجي؟ انتم تختارون؟
احنا اللي غيرنا، احنا اللي غيرنا اللون عشان يبان يعني مختلف.
اما الاحمر والاسود ناتشرال.
الاحمر والاسود ناتشرال عشان الانفراريد.
يجي من الانفراريد.
والاحمر والاسود الانفراريد ليه؟ لان الميه بتمتص كل الاشعه تحت الحمراء بتبان سوداء، بتمتصها قبل ما تحكيش فيه. والكلوروفيل اللي في اللبات بيعكس كل الانفراريد. الاخضر تغييرات في الميه. شايف حته المنزله؟ كل ده دراي داون. يعني دي كانت بحيره كانت هنا كده، دلوقتي ده بقت بحيره هنا كده. كل ده دراي داون اللي هم بيعملوا فيش فارمز وبيعملوا كذا وبيرموا فيها زباله وبيعملوا كذا وكذا. يعني كل ده تغييرات في البحيرات الحاليه. دي خطيره دي الخضراء دي.
طبعا هذا خطر، هذا
خطير.
شوفوا هناك.
لا هي ودي.
So ما doesn't show roads.
لا ما هي يعني لو بصيت
شويه كلوزر. شوف خطوط.
بس
خطوط. هذا الشارع وين رايح على
هذا
اسماعيليه.
doesn't give يعني certain color.
هو لا احنا سايبينها، احنا مش عايزينهم. احنا مش كناش عايزينهم يبانوا.
هذا اللي ناخذه الاسماعيليه.
برافو. فاكر اول فيل ديون اللي بتشوف على الطريق هو
اول شيء
اللي بتشوفه المطار وانت نازل ده المطار.
وهني قبل ما نوصل اسماعيليه فعلا
هم الخضره دي الخضره بتاع يا
وين اسكندريه؟
اسكندريه هنا.
هذه اسكندريه. هذه القاهره طبعا.
هذه القاهره، دي القاهره. وبعدين بينقسم النيل الى حتتين، واحده تروح على دمياط، واحده تروح على رشيد. روزيتا ستون دي رشيد.
شو يسمونهم هذول الفروع؟
فرع دمياط وفرع رشيد.
بس.
فرع دمياط. وين خط القاهره واسكندريه؟
خط القاهره اسكندريه الصحراوي والشهيد اهو الصحراوي.
الله.
ده الصحراوي. هنا هي المنطقه دي.
شريناها دكتور وجنبنا الشعراوي. الشعراوي. وفي مدينة 26 اكتوبر او
6 اكتوبر هنا.
6 اكتوبر.
6 اكتوبر هنا.
لا اللي مقابل مدينة السادات.
السادات اللي هنا دي ياس البداية بتاعتها هنا دي.
مقابلها.
هاي.
طلع عندنا ماي دكتور.
هايله.
يقول لك
ممتازة جدا.
يعني
الريحة تستمر. دي المية دي لن تنضب.
يا سلام.
وبعدين هني عامل له قصرين كبار.
مين؟
اللي هو
الشعراوي؟
قصور مثل هذا.
يقال انه غني الراجل.
هذا من خير السعوديه.
ايوه
لما كانت السعوديه.
قصور يعني ما شيء منقول.
السعوديين عملوها.
تعرف اللي هي يا دكتور الحته اللي احنا بنتكلم عليها دي كلها هنا دي كله ده دي الانسسترال دلتا اوف ذا نايل، دلتا النيل القديم. انا وريت لك الصوره بتاعتها؟ تعالى خلي الناس تشوف معايا.
عجيبة ها؟ جايب عقول انترست هذا فيري في جانوري فيرست.
دي القاهرة مصر كلها وادي النهر ماشي هنا كده اللي احنا بنتكلم عليها. وبعدين لما بصينا على الصور بتاعت أبولو سويوز في الخمسة وكذا بصينا لقيت ان انا في حته هنا الاستراكشر بتاعتها غير الاستراكشرز اللي موجوده في الحته دي كلها. فاتضح انه شايف فينا مثلث كده ماشي شايفه؟ فرحنا على الفيلد وشفنا الداتا وكذا كذا طلع ان دي دلتا النيل القديم الاصلي. يعني كان النيل ماشي من هنا كده وجاي على كده وماشي هنا على اسيوط وكان ماشي كده هنا. كانت دي الدلتا بتاعته هنا دي كلها. بعدين حصل في اليوسين فورت هنا كده نورث ستار
حول الاتجاه
راح محوله كده نورث فعمل لنا دلتا جديد. معنى ان الدلتا دي الاراضي اللي تحت ده كل من ايست اند ويست انها اراضي كلها دلتا، يبقى صلبوخ ورمل وبورس، يبقى كويس. دي معناها ان البروسيس دي تخلي الميه اللي انت بتستخدمها هنا تنشع في الاثنين دول تحتها
طبعا
بس،
ومحتفظه فيها
ومحتفظه بيها. وانت طول ما انت بتزرع هنا، طول ما هنا في ميه
طبعا،
لان طول ما انت بتزرع الميه بتنزل فما يخلص الميه.
دكتور الله يسلمك، متى ابتدت؟
سورس مالها يعني.
لا 15 مليون سنه كذا، لا كثير يعني على مش في الوقت ده. لا يعني.
طيب بس تنشأ على اتجاه اليسار؟
تنشأ على اليمين هنا شويه على بتاعت دي، ومعظمها على اليسار.
بس من بعد قناة السويس خلاص.
ومن بعد قناة لا هنا في كل الرؤى يعني ده ماشي كده
لان على طريق اسماعيليه في استزراع اراضي
اول 10 رمضان
شرق قناة رمضان
والسطحيه اللي جنب الشارع على طول 10 رمضان، وبعدين بعيد عن الشارع شويه السطحيه.
صح.
قصدي دكتور
شرق هنا ده ماشي لحد هنا، ماشي لحد جزء من يعني جزء
من سينا،
النورث ويست في سينا، يعني السهل اللي انت ابيض هو شويه.
لكن في على طريق اسماعيليه، على اسماعيليه في استزراع اراضي اللي يسمونها هناك يسمونها 6 اكتوبر، هنا يسمونها 10 رمضان نفس
فدي فالمهم بقى ايه ان انا عرفت القصه دي ازاي؟ انه في وادي النطرون في البحيرات. وادي النطرون اللي بيقول عليه الشيخ شعراوي عامل فيه اشياء. لما تمشي انت على وادي النطرون قبل ما تنزل الوادي اللي فيه البحيرات تلاقي يعني انت عندك سلوب عالي كده، وانت نازل تمشي لحد سلوب ولا تخلص بعد الارض بتاعت وادي النطرون. وانت في الحته اللي هي منحنيه دي تلاقي الميه بتنشع constantly، اللي هي it is constantly feeding the soil lakes in water. Yeah, where is this water coming from؟ يعني في عز الصيف في كذا لا تنقطع. constant seepage of water من في الحته اللي هي معناها ان you have a continuous source of water. Where is that continuous source of water؟ it has to be the delta. النهارده لما تحكي
اللي يزرعون فيها
اقول لك الميه كانت
كل مره يرشون ما يطلع لنا.
بعدين مو بس كذي دكتور، الكواليتي مالت الميه
ما هي نيل ميه نيل،
هذا مو اندر جراوند،
مش اندر جراوند، دي ميه نيل. انت بتحفر ابركوا على كام؟ على 100 متر 120 130 زي ما انت بديش اندر جراوند. This is surface water. surface water
ما تغير طعمه.
كويس. دي هنا عشان الخطوط بتاع الدلتا باينه فيها كويس خالص. الفرشه دي
هاي اللي يسوي اللياح من اللياح الصلبوخ،
اللياح واللي كذا والكل دي
كل الصلبوخ اللي هناك.
شوفوا في رن؟
يب
الخوريني.
اخر الكويت 3 شهور.
ليش رفضت السعوديه مع قضيه نهر الكويت اللي نتكلم عنها؟
يا قصه طويله. الدكتور علي يعرف اصلها وفصلها.
ولو بس ما قال الكويت.
ايوه صح. ما في شيء قال لك الكويت. النقطة السوداء دي
بين والله تبين.
وده الخط اللي بيوصل لوادي الملوك.
الحين شنو نوع
تي ام ثيماتيك ايمج اللي هو نفس الصور اللي احنا بنشتغلها بالكويت. ثيماتيك ماب سوك ليه؟ ثيماتيك ماب
لان هذه بتطلع الالوان طبيعيه.
احنا خدرناه، لا هو كان احمر واحنا خدرناه.
قاعد اقول حق دكتور علي
ليش ما يزرعون؟
لا دي عالي، دي بلاتو ودي واطيه، راح للنيل، راح للواطي، راح للواطي من هنا.
ليش ما يزرعون؟
انا قلت حسب الله الكبراوي دي كلها وعملته الليله وكتبت في الجرايد فعملوا المشروع ده المخطط ده هي بتقسيمه لدي.
لان دكتور تكلف بايبات وما بايبات وتمديد.
بايبات يا راجل ولا بايبات ولا حاجه مليانه مياه جوفيه هنا اهو.
لا والله
النيل اهو. ما هو النيل بينشع في
ارتواز، قضايا ارتواز.
بامبت يا سيدي.
عندك في ارض مرتفعه ويمشي فيها الماء كرسل في راس النيل.
تزرع فيه في ده كله من هنا لهنا للجبل.
كل هذا يزرعون فيه.
ونسد السدود هنا وناخذ الماء اللي بنستخدمها، يعني ممكن الواحد يتشبع فيها.
لا والله نعم.
كاتب له. ها؟
نعم
كاتب له.
جراج. ما كان في طباعة.
نعم
ما كان في طباعة بالكويت قاعد.
لا كانوا في الطائف، عرفت بيكتب بيده.
21 يناير هذا قبل التحرير.
قبل التحرير 21 يناير اي سي. بعد الحرب الجوية صح.
بعد بداية
بعد البدايه.
الله.
رحت لهم هناك في الطائف. انت ما كنتش هناك، كنت فاكر.
لا
والله
انت اي وقت
رحت هناك. انا بعد ما كتبت الجواب على لندن
اي
كنت هناك في اظن نوفمبر. هم كانوا في الطائف. انت كنت في لندن. شفت الشيخ سعد هناك. وبعدين ده اول ما بدا التحرير ده
نوفمبر.
لكن ها؟
لا كنا في بداية
كان في-
ديسمبر راح نطلع. بداية ديسمبر.
يا
اذكر جيت لي نروح المحاضرات.
فاروق هذا
لا
لا
سالم
هي بس بالسوري الاول يقول لي انت ده بس كان في برنامج في التلفزيون اسمه لوست ان سبيس. فدي الناس بتوع الناشونال جيوغرافيك منهم كانوا بيسالونا كتير على ايام ابولو عشان يكتبوا المقالات بتاعتهم وبتاع كذا كذا. قالوا تو ذا كينج عشان رواد الفضاء كانوا يسموني كينج. الاسم الدلع يعني.
نعم.
عشان ما حدش يعرف الامين ما هو واحد اسمه فاروق من مصر هيسموه ايه؟ قالوا كينج.
الملك فاروق نفس الشيء. الملك فاروق.
عرف انه دلتا كينج مش عارف ايه اسدا كينج وهم في الابولو في الناشونال جيوغرافيك عشان بعد ما خلصوا البرنامج كده كتبوا دي تو ذا كينج without whom the National Geographic would be lost in space. كانت فيها الناس بتوع الناشونال جيوغرافيك.
حلوة يعني كينج فاروق.
هتسميه ايه بالمصري الناس فاروق يسميه ايه؟
To the king without whom the National Geographic would be lost in
من
space.
سبيس.
دكتور هذه الوالدة الله يطول بعمرها اللي وراك ها؟
ده والدتي ايوه. ده زوجتي دي وده والدتي وده البنات الاربعه.
الله يخليهم.
نسميهم اسماء عربية.
معاك دي يعني اولهم منيره ودي سوريا ودي كريمه ودي فيروز. فيروز هي الوحيده اللي لسه معنا كلهم اتخرجوا.
فيروز اللي راحت معنا في السيارة.
ايوه هي
هتدرسني.
هتدرسين عليها environmental science. النهارده ان شاء الله هنعمل بريفنج كذا. كل الشغل اللي لسه هنعمله. وانا كنت عايز اخد برأيك يا دكتور علي في الاشياء الاول قبل ما نروح. اول حاجه انتوا هل بتعملوا اي دعم للاركيولوجيكال ريسيرش ولا لا؟
قدام مع دار الآثار الإسلامية الشيخ حسن.
اوكي.
عملت في الهندسة. معاها أستاذ هنغاريا.
وراحت هناك وانا شفتهم في مصر رحت لهم على الموقع هناك.
اللي بعد ما تحررت من الشيوعية الهنغارية اختار انه يصير سفير. بيكرمونه. هو في اكزايل بيكرمونه فقال انا سفير من الكويت.
هو دلوقتي حاليا
فهو جيزة
ايوه.
عمل
وبعدين بيختفي وبعدين هنا في والد تاني ده كده هناك. طبعا لا لازم يتصل بده بس ده ماشي هنا كده وده ماشي هنا فمفيش حقيقه ضرورة عن الاتصال. الصوره دي بينتها فين الاتصال ما بينهم. ادي وادي الباطن اللي ماشي من هنا كده جنوب وحفر الباطن وبعدين الثاني وادي هنا ماشي هنا. الفرق الوحيد اللي خلاني اعرف ان دول متصلين في هذا المكان انه الساند ديونز اللي هنا دي كلها طوليه كده. شوف ماشي ازاي؟ شوف ماشي جايه من نفود. الرمله جايه من نفود ماشيه كده بالطوليه. تيجي في مكان معاه سادنلي تتغير الطوليه دي لكورن كاب انا سميتها اللي هي الباركانويد ديونز. هم كانت كده ورقه. عندنا احنا قصه زي دي تمام في منخفض الخرجه في مصر. واحد اسمه ابو غرد ابو محرك طويل جدا 300 كيلومتر يجي عند حافه الهضبه اول ما الرمل يتقطع يعمل القببيه دي بشكل القببي ده. فهي معناها ان هنا السكاربمنت ماشي هنا كده.
فولت
اسكاربمنت ايش فولت سكارب ابسولوت لان دي فولت برضه. اتس فولت سكارب. اول ما الديونز بتنزل على الفولت سكارب بتتقطع الرمله وتعمل فانت يو كان ماب the faults the escarpment of the wadi as you go right here. هو في النقطة اللي بتغير فيها الطولي إلى ده.
هذا النهار
معناها انك توصل المية من هنا لعند
الساق اللي هو الساق الجزيريين يسمونه.
يا حفر الباطن ما هو زي ما
هو الاحتجاج اولا يقولون احنا نعرف ان هذا موجود.
صح نمرة واحد.
يعني مو شيء جديد.
وهو معروف اساسا انه فعلا.
الشيء الثاني هذه
هي دي هذه مصيبة.
Images are not photographs. They're digital images. We get them on computer tape. We feed them directly into our computer where we can do our computer analysis of them. The strength in that is we can do statistical approaches to how we deal with the data. and we can take advantage of some peculiarities of the satellite imagery. The main part of that is that satellite imagery are really several images, and that it's a multispectral approach to mapping. We get an image for each, in this case we used 4 different bands out of a possible 7 for the Landsat satellite. What that means is that we get a different brightness value for every point on the ground, and those brightness values are related to what the features are on the ground. And we can then use the computers to discriminate between the different types of brightness of the area around Kuwait. And this is just to show the wide coverage that can be gleaned from the satellite imagery. Satellite imagery also comes in a variety of scales. We used, for the classification, the Landsat thematic mapper, which is from an American satellite. It's 30-meter resolution. Every pixel, which is the smallest element in the image, is 30 meters by 30 meters on the ground.
These are branches of the Kuwait River.
So Kuwait was a delta, actually.
The delta, no question about it. All the way to the Jal Zur. Jal Zur is the last one, the last big one.
This is part of a spot image, and spot panchromatic comes in 10-meter resolution, so the spatial resolution is better. The difference there is that you lose the multispectral approach because the spot panchromatic is a single band. Therefore, it's more difficult. You can only discriminate things by gray tones instead of by colors in different bands. And it's a trade-off in terms of what, and we used a statistical classifier, an unsupervised classification. And what that means is that this was the first level approach. We later used a supervised approach to refine this, but let me talk about the unsupervised approach first. What that means is that the computer decides how many surface features there are. You give it a broad, a general range of values, and it will say, okay, we can go in and we can find all of these different things, and these are what is most like each other, and assigns those to a single value. When we color those values in, we get a map that looks like this. What you can see is it's taken some broad surface categories, some of which are fairly obvious. For instance, here's the Fergana oil field. Downwind of that is all of this sort of maroon brown tone is the deposition from the oil that fell out from the burning oil wells. And then we have other things. Green and yellow classes are more sand, drifting sand, at various levels of vegetation cover, various levels of damage caused by the war, various types of desert surface. For instance, if you go out and there's a desert pit, and we went in and took some of the areas that are some of the urban areas and some of the areas out in sand fields and broke those down and better defined as classes.
المي داخل المي
ما ضحك
ميه ضغط ميه ضغط ايوه راه صح صح
الزراعه الحفاظ على المنطقه هذه كلها
كل ده صح.
The darker the deeper, right?
The darker the deeper.
Now, classification is a very strong approach for doing this type of mapping. You can determine a lot if you have good field data and if you have the proper algorithms and use them in the right way. One strength that you can do is that you can do a comparison between dates, and Augustine will be talking more about change detection, but one way of comparing or assessing change is to do a visual interpretation of pre-war and post-war classifications. Now, the colors don't match exactly, partly because the classes that were existent at the two different dates don't match exactly. Before the war, it was a less complex scene than after the war. The war activity introduced a lot of diversity to the landscape in terms of the damage caused to vegetation, damage caused by the deposit of oil.
This one is post-war.
That's pre-war.
Pre-war.
That's pre-war.
Pre-war.
Right.
Post, yeah.
You can actually see, if you look at the same area in the Al-Hamadi and Fergana oil field, that you can see some of the infrastructure, but really there was not much environmental impact in terms of broad areas being impacted by the activities in the oil fields. After the war, because of the deposited oil from oil spills and from the atmospheric fallout from the misted oil, there's a huge impact around the oil fields and downwind from the oil fields. And it's the most visually strong of the impacts of the Gulf War. The other thing that you see is that we had various levels of active and semi-active sand through the broad area in the southeastern central Kuwait. After the war, we have huge influxes of mobilized sand, and a lot of that sand was mobilized by activity during the war. And so it's a very quick and easy way to compare. Now, doing change detection, what we're talking about is more...
خندق السعودي.
Yes, خندق السعودي. ودي الوفرة.
What do you mean by impact? I mean when you analyze the word impact, how do you?
Well, actually, we have not really made an assessment of actual impact. If you want to talk about environmental impact,
But the impact assessment is being done by our colleagues that we're working with at KISM. They are specialists in the impact assessment after we tell them exactly what happened. Because there's a change.
هذه واضحة.
كثير الدخان.
وبحيرات النفطية وين؟
كل هذه بحيرات. شوف ايش كثر.
السوداء هذه.
كل هالبقاع.
والخطوط دي كلها طرق جديدة.
ايه الطرق البرية اللي بالطيارة تبين واضحة.
اللي بساعة.
صح.
اللي بنوه عشان الحفر عشان
يطفون الآبار.
طفوا الآبار والكلام كله.
وصايرة بيضاء والأرض هي سوداء مسويتها.
والألوان اللي هنا كلها دي variations in thickness of the layer of tar crete. Yeah. As you go in here, as you get into the thickest layer right here, up to 15 centimeters thick. 15 سنتي بالنفط جامد مخلوط بالرمل.
طيب.
So it actually, and then once we had this, we didn't stop there, because what we were able to do is use the field data from this scene and use the information we got in doing the classification of the scene and extrapolate that information to the other 4 Landsat scenes, satellite images, that cover the rest of the country. And then what we did was we went in, we did the class extrapolation after we'd done the classification on those scenes. We mosaicked those together, and we actually come up with a final image that includes the entire country. And these are what we will be making into map as our final output from the with labels.
Yes, هذه الجديدة دي الخامسة. إن شاء الله يكون عندك نسخة منها دي في خلال 10 days. Okay, I'm ناخد ملخص بالصور دي. امسك السمري بالصور من الأولانية. شوف يا دكتور علي اللون الأخضر الفاتح. How much sand has been mobilized in basically 2 major areas. One just west of the oil workers, and one in the corner where the Iraqi army was most highly concentrated. على الكورنر ما بين السعودية والكويت والعراق. Yeah. And then the purple is up in the north and Sabriya والرابطين. Also same way.
قصدك هذه دكتور؟
فوق ايوه ده الرمل. لكن اللي فوق الزرقاء دي فوق شويه كمان روضتين وصفريه فوق هذه فوق كمان فوق
ها هني فوق اوكي.
هذا مرمم.
طيب برا الناس هناك الحين.
Very good. Is it sorry or no?
And that's it in terms of classification, unless there are any questions.
So this is basically how do you classify the satellite image. Yeah, and how do you make separate classes to begin to understand later what these classes mean. Yeah. And the most significant piece of finding out what these classes mean comes out with the work of Mr. Master Degree Ahmed Al-Dosari, the director of the Remote Sensing Unit of the Earth and Environmental Science Division of the Kuwait Institute for Scientific Research.
وبعدين ما يخلونك ترجع.
That's right.
يخلونك
If they
تكمل.
hear all of this, that's
We used the 6 bands of the Landsat, the American satellite, and we took that piece, as you see back there. We took that's the
original.
That's the original that we took to the field. Actually, it's a piece by piece. We just mosaiced them together by hand, and we took each part. We go to Kuwait. We would take specific part, and we just identify each class we want within that. Can you please turn on the slide? Generally.
Where we are.
هذا تقريبا shows you where's Kuwait in the map. As all of you know, this is Saudi Arabia, Iran, Khalij al-Arabi, تقريبا Middle East. Looks like this. هذه actually في 89. And the image in 89 did not have much feature, as we're going to see on the second image, where 89 did not have the long trail of tarmac or suit that has resulted from the flow of over 7 oil wells. And here we don't see any disturbance, at least with the movement sand. It's not covering much of the area. It's like this. And as we see here, when we use the unsupervised classification technique, we segregated all the classes, and as Dr. Farouk mentioned, the degree of concentration of the soot can be seen around here. And if you see the moving sand from the northwest wind going all the way south to the border of Saudi Arabia, plus you see it, the soot is parallel to what's the movement of sand in a way. We see the city is covered by one color. Here there's other color. This area is mostly by concrete on the surface, and we see the same soot are appearing up on the oil fields, plus some of there, right here, Managish, part of the Managish oil field, the Wafra oil field, right here, and it shows the oil and the soot, and plus you see the oil lakes with the dark blue if it's clear down here. The water difference, this is the degrees of the ocean, of the Gulf, and it's probably because of there was low tide and different surfaces from the beach, low water, then deeper water. Here we see the vegetation, which really not much of change happened around this area.
The desert surface, the vegetation is in water. This is a normal desert surface.
Yes, and we see the Wafra down here, the farms are covered by the same color, which will Soren later on have segregated into different classes, and the city plus the airport in this area and Jahra in this area. It's like that. We have taken the radiometer, and basically this is Dr. Fikri, myself, Soren, and another colleague from Kisa. And basically the radiometer is handheld, as you see, as an instrument that operates almost the same way that the Landsat scanner works. And the way it works, we can direct it by command from the buttons here, and we record the data in a specific tape that was made for this purpose. We set it ready. This is the electricity hookup to the terminal. If you are in a building, you can take it with you in just a specific battery that will make it operate. This is actually the scanner. The scanner is very specific, have very specific use. You would hold it about 1 meter above the surface in order to reflect the light. But before we do that, we have what's called Lampertian panel to help us calibrate this surface to color. Actually, nobody can measure the light or radiation. So we have this this Lampertian panel was made just for that purpose, to have the maximum of light reflection. So
with each and every measurement, you start with this so that you can calibrate the measurement.
Measurement of here.
So they can relate to each other no matter what time of day or what the sun angle is and where are you.
And exactly, as Dr. Farouk said, there is some other effects. Sun angle, the clouds cover, and this instrument have to be used in certain hours by the day. That's what one of our problems in Kuwait. It was cloudy sometimes. We have to wait until another day. We already went to the field, but we have to take it another time. When we take the immersion panel, we take our measurement, and as you see here, we're taking and we're inserting our commands to be recorded in the tape right here. Later on, the late stage, after we finish our purpose right here, recording it correctly, because there's a digital phase right here that we see if it's correct, recorded, we give it a specific number to be stored. We have the GPS, Global Positioning System. That's probably familiar to the fishermen and so on, people that travel far away distance to locate there. The purpose of using the GPS, we're trying to locate an area on the ground, on the earth, almost 30 by 30 meters. From the image, this image, probably over 72 million pixels. We're trying to identify one specific pixel, and that was a great help. We take it, then we try to insert it into the computer, and we'll locate our place on the ground. On a later stage, we take the information from the tape, we insert it into portable computer, and we take the data out, do some analysis. Finally, we take it into the bigger system where we can analyze it and compare it to the final objective that we want. And as you see here, we're somewhere around the Wafra, and this is the Burgan area. And we see that the tarmac is really covering the area. This is like a rest area for trucks. And what you see as these different colors in the fields. And that's exactly what it looked like between very hard cover of suit and moved suits where they can move around the city and around the desert. These are the clearance. Actually, the disturbance did not only happen through the war activity, but after the war activity, there was more disturbance to the surface. As we see, there's no evidence of vegetation at all. But you see the surface is being covered. As you see, the sands are moving and covering, and probably in the process of moving to somewhere else. These people are clearing mines. The mines have first place disturbed the earth where it was placed there. Now these people are trying to move it. So the disturbance is happening again and again. This is destruction of probably radio station power at the Wafra road from Mina Abdullah to Al-Wafra. And as we see, disturbance are on even after the war, not only before the war.
Ahmed, if you look at the picture like this, will you be able to say the direction of the wind the last few days?
Well, from the sand trails right here, drifts, you can see that the wind is coming this way because actually somebody, special geologist, knows this the topics of. You see the sand drift is kind of a line right here, then it goes on and on.
I just wanted to see
Southeasterly wind.
The shadow.
No, the shadow.
No, actually northerly. No, this is the south, this is the north.
That's right. Yeah, I was just wanted to make sure that you know this because I wanted to show you that sometime, and that's an excellent example. Because you have a little rock or a vegetation or something, a clump, and you make a sand shadow behind it. So that will tell you that
This is naturally, in military purposes. When you dig a bunker, you try to dig it in a high place, on a hill, what do they call it, sayhead, just to at least get control of the area around you. Now we see the land right here have almost no sand, but all the sand was here and moved, covering. You see the bunkers. So this is only after the war. This is a result of sand movement. You have to go there and see it to know how much it will really move. You see the wind erosion taking place, or this calculator taking the vegetation here could not be grown on the top of the sand dune. It was grown up before the sand dune by sand dune covering.
But just
Yes.
question. I wanted to ask Dr. El-Baz a question.
Very thick layer of soot and tarmac, but we see vegetation are penetrating again by a strong will of God. It's a good habit to see, but we still have another problem of disturbance. This has happened after the war. Somebody came in here and drove over this, killing wildlife and disturbing the surface again and again. Public awareness is very important in this matter. That's moving over the surface of the desert takes a lot of. I mean, when a car moves in here, will kill vegetation in this way. It will take a long time to be grown. Take a long time to regrowth again, and soil compaction would be concentrated. But, in our investigation, as we see there, we had the most significant we found from our statistical analysis before we select any of our measurement. We find out that the dark blue class, which is the oil lake class, you see oil lake, soot, and damaged vegetation. Damaged vegetation, actually, I said dense damaged vegetation. I meant it because it's on the lowland area where the drainage system all be ending on the place where they give a chance for availability of water to have more growth of vegetation. Soot, of course, the oil lakes and shrink because of other factors that evaporate or the sucking of oil, and left the edges of it as very thick soot or tarmac. Oil lake, of course, the one right in the middle, that's the main problem. This is actually the sand movement class, which became the light green, as we said earlier. And we see we have the soil colors are divided into 4 parts, which carry 7% almost, except the tan, which was the color of the soil. We took the color of the soil and the vegetation density, the contamination of oil, and we took the type of surface, what type of lags are available, what type of soil are there. So we divided them into 4. The first one was the color, and ended up to the yellow color, but 17 took the most of the color in the green class. Then we go into the vegetation, where we see no vegetation at all, I mean 3%. Then we go dense vegetation, it takes 7%. Then you see sparse vegetation takes a long 23 part of the pie, and we see most of this class, 33%, as purely sand, no vegetation. This maybe had certain color, 17%, most of it, but actually took the most of the pie from the result of our statistics. Next slide, please. The reason I showed only 2, because I wanted to show 2 things here. Now, this is a test site number, where we went. Each site was number. This is the brightness value of the Landsat. This is comparison between the radiometer and the Landsat. I'd like to mention that the radiometer was taken from 1 meter height above the surface, and the satellite in orbit about 500 miles.
70 miles, yeah. 920 kilometers.
Above Earth's surface. And this is how much are we accurate. We see dark blue, as we saw earlier, is the lowest brightness value from both. And we see the light green, which is the sand movement, the highest in both, at least on the Landsat. And you see it almost right here. It's one of the top the top digital values that we have for the radiometer. Also, the radiometer are taken by nanometer. So the measurement of it really slim. But the Landsat shows much difference because it was measured in the long wavelength.
This is one of the critical results of the master's thesis.
And
The neat comparison, comparison between the two measurements taken by completely different scales.
And this is the infrared. We've taken four bands. On the radiometer measures in 4 bands only, where we had a comparison of 4 bands that are parallel to it on the scanner of Landsat. So we have taken, because it shows all the bands have shown almost exactly the same difference, but because the wide variety of change or shows clearly on the 4th band, which is the infrared, the highest point and the lowest point in the orbit.
The next step from the scientific view, the scientific point of view of Dr. Ali, is the fact that, okay, now we know these correlations exist. Now, from the scientific point of view, the next question is, what is the chemical reason for these variations very specifically? So we might find somebody in the Kuwait University to pick up a little program and buy one of those and figure out the real chemistry of the soil as the cause for the change. We now know the change, and we know the correlation exists. Now, what are the chemical causes? Okay, the next scientific question.
Another thing might be what I'm looking for is atmospheric correction, for example.
Yeah.
Because are all these taken on the same day?
No. No. Yeah. But which actually means that the variations are exist and they are much bigger than the potential atmospheric variations. Actually, you're right. The next thing to do will be someday to make measurements in the field the day the Landsat satellite passes over. Absolutely, you're right.
The reason we made the statistics, as Dr. Farouk said, we try to describe the behavior of the radiation when it comes back. But actually, the chemical compound of causing this reflection, as Dr. said, needs another investigation. And this chance, I'd like to express my thanks to Dr. Ali Shamlan. Actually, he's the behind the whole project, and I'd like to express my appreciation for his support, encouragement, and also Dr. Farouk El-Baz. He helped me from day one since I came here, and I'd like to express the best things that I ever done in my life, and typed every word of it, and every single many times.
As you see here, these are the two southeast parts of Kuwait. This is in 1989.
Before and after.
Yeah, June 1989, and this is November 1991, before and after. My technique, my goal was to produce a change image or a change map, basically showing where the area has changed from here to here, and where there is no change or significant to no change. The technique that I found that is very suitable to this kind of study was the regression technique, and a little bit more into a modification to it, which I call a categorization of change. The basic technique is a regression technique, and in regression what we do is to try to predict what would have been the scene in 1991 based on the conditions of 1989 if there was no war. So this was
كان هي 8 هي 14 كانت 6 هي 14. Yes, perfect.
It's a statistical measure. What we try to do is similar pixels. We try to find the statistical relation, and what we yield is an image of 1991 predicted based on the conditions of 1989 if there was no war. So that was the result of the first run of the regression, an image of 1991 with no war. The second step was to subtract the actual conditions of 1991, which is as was measured by the satellite, and the one that was predicted based on the conditions of 1989. One of the nice things of this technique, regression technique, is that it allows us to get rid of all the atmospheric effects. For example, this was taken at, in the summertime. Probably there was no so much smoke.
And it was high tide over there.
Yeah. So, and the illumination was different. The sun angle was different from the time the satellite was passing here and passing here.
And
so
this we couldn't control because we had to live with the data that was taken available.
There was no way that we can
At the
control.
same time, observation.
This was the resultant difference image, which is the resultant between the predicted 1991 and the actual measured 1991. And as you see, when you subtract these images, the areas that didn't change will be basically will have zero values. The areas where there is a significant change, for example, this area was very bright. Now it is very dark. So when you subtract this from this, you will have this a very big you have a high value here. Or depends on how you subtract. If you subtract here from here, it will have a negative value and so on. So basically, if you look at the sea areas, it's all homogeneous, which means there is no change here, or there is no. And here some other areas too, showing there is no change. Now the goal from here is to put a threshold, or to play around with the values of from the resulting subtraction, is to say, okay, this area, all the values in this area are changed. All the values in this area are changed because we went to the field, we know that this area is changed, so most of the values are really changed, and so on. And you apply this threshold through the whole scene, and basically to the whole country because we have the other class too. But that was very difficult to do because if you have a threshold that will hold for some parts here, it will not hold here. If it holds for some areas, it doesn't hold for the other areas. So that was a big problem. The modification that we did was to categorize the change classes. We know that there are classes here that change, or spectral features that did change, and we know that there are some other areas that didn't change. So the technique that I followed, this was done for band 5, the infrared band. The technique that we followed is to include another band, for example, band 7 or band 4 or band 3. We found that band 7 was also very suitable for this type of study. And then classify, use the same technique that Soren was doing. Apply a classification, and this will yield the classes of change. Or basically, what it will yield is will yield classes on the scene. And then the people going to the field, Ahmed and Soren and Dr. Farouk, would sit down and say, oh gee, this is a class of change, and this is a class of no change, and so on. And this was the resulting image.
That's the real change detection result.
This is the change reaction. This is, we run the classifier with different number of classes. For example, we run with 5 classes, then 7 classes, and 10 classes, and so on, until we reach a final agreement on how many classes are basically on the field, based on the field observations that were done by the other colleagues. This was the SIG dark red, the basic oil spill, and then as the other colleagues were talking, these are different variations of the concentration of the dark red on the ground. The gray. The green was some minor changes within the city and around the oil fields. The yellow, or most of the yellow, was to mobilize sand that have been shown in previous videos. And
this is mobilized since the difference, the mobilized between the two heats. So that's a great deal of sand to have been mobilized within a year and a half.
The blue is the water, and the areas, the orange areas, are little to no change. This was hard to categorize, or hard basically to put an exact threshold to say, okay, this is no change. It's still, there is little change, but it's not that significant that you can call it change compared to other type of changes. So this is why we sort of labeled it as little to no change, because it's a little bit of a change, but compared to other types of change in the whole scene, in the whole country, it's not that significant. So we labeled it as change, little.
Abdulkader, the set that we made with the 10 classes agree with all of the military maps that Rafik Misak is working with at Kisar now. So it's a good thing that you made the tape with the 10 classes rather than the 5, because the details on the maps that they're working with is from the 10. Yeah. It shows a lot more than the 5.
Yes, yeah.
So this is a good general view.
This is 6 classes actually.
6 classes, this is a very good general view.
Yes.
The 10 classes show more detail and it's useful for Kisar.
Okay, did you do, I mean,
which was one of the environmental damages caused by the war. So the first slide will show you a GIS overlay of different information mapped from digitized from maps. Each color represents a different map layer. Here we have the location of the oil fields in the UAE and the oil wells on the map. And
there's a lot of trees here, but this thing is cloud.
And we have the scene, we have here a scale, which means that each layer is geo-referenced. It has an exact geographic location, and you can do all kinds of measurements, area measurements, distances, etc.
The red dots are the oil leaks or the oil?
Yeah, these are no, oil wells.
Oil fields, oil wells.
As mapped from 1 to 250,000.
Within each field?
Yeah.
Yes. And also the boundary of the country was digitized from okay, the next slide shows you the incorporation or integration of satellite images, in this case spot images, with map data. And in order to do that, we decided to use high resolution satellite images, spot unchromatic, gives you a much better accuracy. And there are different steps involved in this integration. First, you need to enhance the image so that you actually see the features you're interested in. In my case, in this case, oil plates within the oil fields. That's why the entire image is very bright. That's on purpose. The other step was the image is enhanced. You need to register or rectify this image according to topographic maps, which means you locate features here on the image and try to find those corresponding features on the map, and then you assign the right coordinate. And then you apply a transformation matrix, and it converts, it stretches or whatever the image so that it fits exactly in a geographic coordinate system. And you can see here along the coast that it matches the boundary as mapped from another source of map. Okay, so we chose 5 images covering the main oil fields, and the next slide will
can you please raise your voice?
Yeah, okay. There is a lot of noise on the back.
This slide shows you, it's a close-up of Bogan oil field, and it shows you the raw data before processing it. I mean, it's sort of a little bit processed. Next slide, we see the result after applying several techniques, stretching and also enhancing edges, because the boundary of oil, of those oil lakes, they have, contours and edges, which can be additionally enhanced. And here we see that these oil bodies were not visible on the previous image, but they are visible here. And all the lines within this dark area are the new roads that were built during the extinction of the oil fires. Okay, the next slide shows you graphically what was done to to the image. This is the histogram of the raw data. It shows you, gives you here a scale from 0 to 255 representing the different pixel values, brightness values. 0 being dark and 255 being bright white. And the amount of pixels, falling within each pixel values. What we did here is that we stretched, especially this area. That was done by exploring the image and looking what brightness values correspond to the dark or the polluted part of the image. And so we stretch this part here, basically, we increase the contrast of the pixel values. The next slide shows you the result again. And this is even a smaller area. Just to show you the process of mapping now the individual oil lakes. There are two approaches that were used here. One is you can assign certain ranges of brightness values to a single color to make it more visible, because you can distinguish better colors than gray values.
What is the scale of this one?
This scale is... yeah. I think
It's about probably 20 kilometers. About 10? 10 kilometers.
I mean, you can zoom in even more, and you start seeing the... while the digitizing was done, actually, parts were individual oil lakes were zoomed in. You had this here, you could see each individual, But this is just, for showing you, now the different techniques. And one is to assign colors to a certain range of brightness values. For example, this one here, it's called density slicing of the image. And the next slide shows you that you can interactively add more and more pixel values, or assign more and more pixel values this color, and you can see how that reflects or how that shows up on the image. What happens is that certain oil lakes start, in red, but then again here within this oil area, certain pixels show up as red, which is not the purpose of this mapping. We're only interested in oil lakes. So we decided to combine, this would be a quantitative approach with a qualitative approach. Since we know that oil lake bodies, they have a certain shape, irregular, for example, as opposed to man-made pits, which are squares. And we can just visually delete or just remove those oil bodies that were picked up by the computer, and or we can add certain, or we can just trace the line border of the oil lakes, or just looking visually. The next slide shows you how the border were traced, and this digitized layer was then superimposed. By a digitized layer, I mean with the yellow, because the background is one layer, and the yellow is a vector file, which is another layer. So you can separate them, you can merge them with other type of information.
You know when this picture was taken?
Exactly. It was 25th of March, 1992.
That's another thing.
25th of March 1992. A year ago.
So this mapping is just
5 months after the last one has been built up.
And I'm going to say something about also the dates. I mean, this map is just representing the situation as of March 92. Okay, the next slide we see is the overlay of the traced or digitized boundary and the density sliced image. And you can see that some corrections were made. And this was done for all the orbits. And so a map data by map layer was created showing all the digitized orbits. Next slide.
How can you differentiate between the water pools they
for that
built
right.
for putting out fire?
Well, that's actually a problem which you can solve that just by looking at the image. You need to have additional information. So you need, or you go to the field, or if you have aerial photographs showing.
Absolutely ancient all at the time, yeah. But you have the case. You have a good case here of a water pit that looked dark, and then you saw where the oil was, and you separated between the two. You have slides of this or not? Yeah. And
what's the difference in color?
The difference in color here, because this is not the spectral. I mean,
it's black and white. So it's very difficult to separate the spectrum.
Yeah, so it's basically impossible. But you can choose, other criteria. For example, you know that if it's not within an oil field, then it's probably not going to be oil. Right? If it's somewhere, who knows where, in the urban area. And the other one is spatial. I mean, just by looking at the shape.
Because they were squares.
I think that's the only way.
They were squares.
That's the best way.
That's the best way.
Squares. Yeah. Right.
Yep.
And the other.
They make them very nicely
squares.
Well, then you have also sometimes problems with buildings that are burnt. Right? Sometimes looking at the map and seeing where are those installations, tanks or whatever. You say, oh, okay, this is probably a burned out tank. I mean, yeah.
So it has to be interactive.
Yes,
there's a lot of interpretation.
And certainly, if someone who has been there, just sitting near you, tells you, this is something else, and that's the best.
Then enough tanks, storage tanks, would look exactly
the same. But we also, she had the map of Kuwait, and she knew where these tankers were. So that helps too. So you can. So they knows the location. So there is a little bit of interactive thing. She means to say that you cannot do that in an automated way by the computer and depend on what the computer says.
It helps you to locate areas which maybe you missed because you didn't see them. You say, oh, okay, this red spot. What is it? What is it? So it guides you in a way. It certainly helps you. So the next one. Well, this is then actually the digitized oil legs and then converted in raster data. Next one. Here we have some examples from other oil fields, in which I think what is interesting here that you see as of March 92, some oil legs are still filled with standing oil, while others have dried up. So some of that oil is probably the soil.
So all of these kinds of things would be soil saturated oil.
Yeah, but there were.
But it's no longer fluid on top, but it is still a lot of oil, but has soaked into the ground.
Or
just evaporated.
No, or pumped, yeah. But even wherever they pumped, there is some oil left over.
Yes, and there was at a certain point there was oil.
Yes.
And also some of the oil just flows along the drainage. And if it rains, then the rainwater is probably going, along the valleys, the drainage line, and it will take some of that oil and eventually carry it
towards the sea.
Downstream, yeah. So what she was trying to do really is to map standing oil as of March 25, 1992.
In the next couple of we have here, that's again another.
That's in New York.
That's the product name. So you can see that, for example, the number of oil legs. It's dependable on when you did the mapping, because at the beginning there were, let's say, fewer oil legs, but they were bigger. I mean, the area was, and they were connected what happened here is that, especially I think you can see it here.
Yeah.
This was one oil leg. Now
Yeah.
there are like 10 little bodies. So it's difficult to say what's the number of oil.
Right.
The difference in here, just quickly I can say, is that the lakes in here are probably just moving within wadis, you know?
Yes,
Yes.
all because the topography is very different.
Yeah.
Very good. Yeah. The topography in the topography in the south is nearly a flat. There is just a gentle rise and it's all flat land.
Right.
So whatever and with little hollows here and there. But the topography in Sabri and Raudatin, there is a little ridge east of the two valleys, and there is a lot of drainage lines all going in this direction. So all of the oil lakes in Raudatin and Sabri are elongate rather than round. Yes. And that's the difference in the surface topography. Absolutely correct. Yeah. And we're different. I mean, when you look at the pictures, you know exactly where it is. And in the north, they're elongate. In the south, they're round.
For example, one way of figuring out what are factors, influencing the distribution of oil lakes is by superimposing a topographic map or geomorphological map or drainage map, and then you figure out, what factors are, influencing in this particular case the spatial distribution. In our case, probably not topography as much as. Okay, the next couple of here we have also there are differences between the oil fields because of the number of oil wells. So we have certain areas which haven't been that much affected. As for example here.
This is the one without the jealous door.
Yes.
Yeah.
Okay. This was probably also a former oil.
It was a very big, yeah. I saw it.
Here you have the scale. Okay, the next slide is so Nadish, and I think the next one is which has a small oil field. Here we see very clearly the sand.
On top of the sea. So all of this, we know this, that all of this was dark right here. All of this, and this is all new sand.
Which illustrates you again the importance of mapping. Because if you don't map,
and so there is a thick layer of oil underneath all that sand.
what is underneath it. And since the sand movement slopes quickly, I mean it's
Sand?
yeah.
Forever.
I think this picture also illustrates the importance of mapping, let's say in November, just right after when they finish maybe extinguishing the earth. And then maybe 2 months later, 4 months later.
And after the windy season and
right.
that,
And monitor this.
Do you mind if I have a comment? So the top of the slide, there is different color than actually on the right and the left.
And that's the new sand.
And that's exactly proof that the sand moving and also covering.
All of this here is the natural desert surface. And all of this is the new sand movement.
And you see how they cover even the smoke in the tarmac that was created. And it's moving, it shows the parallel lines from the wind direction.
I think that one important thing to consider is that, for example, in this oil, the tar creek, it is in fact the area covered by the tar creek is
enormous. Because there are fewer wells,
Yes. And in the case of Bugan and Lakwan, we have this incredible area, which is basically stabilizing a little bit, the sand. Yeah, the sand. So it's not.
That's a good point.
I think that's why you don't see these type of features in Bugan yet.
On the sides.
Okay, the next one, Suatra, where I have one example, which is this feature here.
Yeah, that's one of these water.
The water pits. Yeah. And there we have to pick up on the computer as art.
Yeah, because this dark in here is water still standing in the sand.
Yeah. And in the next slide we have an enlargement, and you have 2 different dates. The same area, but it was taken in November 91, and this one in March night. Months.
So this is water heat, yes.
This is
And
the
this
water.
is dried up. So, but that is leftover water.
Yes.
Doctor, this is mine. This is close to one center where they leave the unwanted water, the last stage of oil. They pour it with the water, Doctor, to be saved in this this pool to be for the purpose of evaporation. And actually, one week to another, you might see a difference. I looked at it in the image, and I always, in each image, it looks different. I said, I must go and check it out, and went, and it just
the sheen on the top.
And I think that oil is just, if there's oil, it's just dark. Yes.
Yeah. It's possible, but except for the fact that I want to